Welcome to Unit 7. This is Applications of Derivatives. We want to use derivatives to help us solve real-world problems. This is Lesson 1, Derivatives in Context. We want to know what derivatives mean in a real-world situation. So first of all, the word context in math. Some examples will help. Number 1. Maria saves $10 every day. She has $40 right now. Well, if she saves $10 every day she has $10 more. The slope is 10. The y-intercept, that's the starting number, 40. Context is, what is this problem about? Well, this problem is about money, how much money Maria has. So the y-intercept in context, she has $40 right now. So the y-intercept is money Maria has right now. That's the y-intercept in context. That's what the y-intercept means in this problem. So if the y-intercept is 40, that means Maria has $40 right now. Number 2, the temperature goes up by 10 degrees every hour. It is 40 degrees right now. Okay, the slope, well, it's going up by 10 degrees every hour, right? So the slope is 10. The y-intercept, that's 40, because that's the temperature right now. So the context, well, this problem is about temperature. So as you can see, context is really what the problem is about. Okay. So y-intercept in context, the y-intercept is 40. What does 40 mean? Well, 40 is the temperature right now. Number 3, f of x is equal to 10x plus 40. Well, the slope for this one is 10, because y equals mx plus b, m is the slope. The y-intercept is 40. Context? Well, there's no context. This isn't about anything. It's not about money, it's not about temperature. It's just a math problem. So we can say there's no context. So we can't say what y-intercept in context means because there's no context. Notice that the math for all three problems is the same. Slope is 10, y-intercept is 40. But each problem has a different context. 1 is about money, 2 is about temperature, 3 is about nothing. Okay? So in this lesson, we want to understand what functions and their derivatives mean in context. To understand derivatives, let's review what is a derivative anyway. Well, a derivative is really just a slope. It's the rate of change. It's how fast something is changing. For example, if C of t is equal to the number of people with COVID-19, where the unit is people, and t is the number of days elapsed. Elapsed means passed by, like how many days have already happened. So if today is Tuesday, and t is 2, then Wednesday, Thursday is t equals 2, Friday is t equals 3, and so forth. Okay. While if C of t is the number of people with COVID-19, then C prime of t, that's the rate of change of the number of people with COVID-19, right? Because derivative is rate of change. What does that mean? What does rate of change of the number of people with COVID-19 mean? What does that even mean? So for example, if today, let's say that today, which is C0, today there are 30 people with COVID. If tomorrow there are 40, the day after that, 50, if it's going up by 10 every time, if it's 30 to 40 to 50, then it seems like the rate of change is 10, right? So really, the derivative is how quickly COVID-19 is spreading. If the way you can write it is just the rate of change of the number of people with COVID-19. What unit is this derivative? Well, the unit of C prime t is always going to be the unit of ct divided by the unit of t. Is how many people contact COVID-19 every day. So if C of t is the number of COVID-19 people with COVID-19 and t is the number of days, then the unit of the derivative is how many people get COVID-19 per day. Okay. So for example, if C prime of 5 is 600, that means that the number of people with COVID goes up by 600 on day 5. So 600 more people got COVID. That's what that means. Because if the number of people with COVID is growing, we would expect C prime of t to be positive. Okay. So let's use this as an example. The number of people with COVID-19 after t days is given by C of t. C is the number of people, and the unit of t is days. For a given city, C of t is equal to 600 e to the t power. Okay. So first of all, part A, find ct. Find C of 2. All right, so we're just plugging in 2 for t. That's 600 times e to the 2 power. We can go to our calculator. E squared is about 7.39. So 600 times 7.39. So multiply this by our 600. So I get about 4433. So C of t is 4433. Part B. Explain the meaning of C2 in the context of the problem. Well, if C of t is the number of people with COVID, we know that C of t equals number of people with COVID-19. Then C of 2 is the number of people with COVID-19 on day 2. So if C of 2 is 4433, that means that 4,433 people in the city has COVID-19 on day 2. That's what that means. Okay. All right. Part C, find C prime of t. Okay, let's take the derivative of ct. C of t again is 600 e to the t power. The derivative of e of t is just e of t. So C prime of t is just 600 times e to the t power. That's the great thing about e to the x. Well, so that means that C prime of 2 is going to be again 600 times e to the 2 power. We already did that in part B. It's again 4433. But C of 2 and C prime of 2, while they all have the same number, they mean different things. The meaning is different. Part E, using correct units, explain the meaning of C prime 2 in the context of the problem. Well, C prime 2 is the rate of change because of CT. That's the rate of change. In other words, it is how quickly the number of, it's really how quickly CT is changing. CT is the number of people with COVID-19 is changing over time. It's time because T is time. So C prime 2, then, so C prime 2, well, it's over time. It's C prime 2, so it's how quickly the number of people with COVID is changing on day 2, because 2. Units of the unit of C prime 2 is going to be the unit of CT divided by the unit of T. The unit of CT is people, the unit of T is days. So if C prime 2 is 4433, that means that the number of people with COVID-19 increases, it grows by 4433 on day 2. That means about 4,400. That means 4,433 people, new people, got COVID-19 on day 2. Okay. Example 2. The height of a roller coaster is given. Sorry about the noise. Let's start again. Example 2. The height of a roller coaster is given by the function h of t equals 20 sine of 3t, where h is the height in meters and t is the time in minutes. Part A. Find the height of the roller coaster after 0.5 minutes. Well, height is h, so what we're really looking for is h2. So h2, we plug it into the function, is 20 times sine 3t, so 3 times 0.5. So that's 20 sine 1.5. Plug that into Google, to a calculator. I get about 19.9. Okay. And since h is the height in meters, that means that h2 is 19.9 meters. So the roller coaster is at a height of 19.9 meters after 0.5 minutes. B. Find h prime of 2. So let's take the derivative. If h of t is 20 sine 3t, then h prime of t is 20 cosine 3t, because the derivative of sine is cosine. We take the chain rule, so we have to multiply by the unit of the derivative of 3t, which is 3. So it's equal to 60 cosine 3t. And so h prime of 2 is going to be 60 cosine 3 times 2, which is 60 cosine 6. Plug that into the calculator. Cosine 6, we use radians. I get about 57.6. Okay. C. Using correct units, explain the meaning of h prime 2 in the context of the problem. We can use the sentence starter. H prime 2 is the rate of change of h with respect to, h prime t would be the rate of change of h with respect to t. Okay, so I'm just writing it out. H prime t is the rate of change with h with respect to t. H is height, so I replace h with height of the roller coaster. T is time. Okay. The unit of h prime t is going to be the unit of h divided by the unit of t, which is meters divided by minutes. Meters divided by minutes. That means that h prime 2, well, if h prime of t is the rate of change of the height with respect to time, h prime of 2, which is equal to about 57.6, that's going to be the rate. So we know that 57.6 is the rate of change of height with respect to time in the units. The units is going to be meters per minutes. So h prime of 2 is the rate of change of height with respect to time in meters per minutes. So every minute, the height is going up by 57.6 meters at time t equals 2. That doesn't seem very realistic. It's probably too fast, but those are the numbers for this problem. Example 3. The amount of money over time is given by the function m of t, where m is in dollars and t is in years. M of 5 is equal to $6,000, and m prime of 5 is equal to 2,000. A. Explain the meaning of m of 5 in context. Well, we know that m of t is the amount of money over time. That means that m of 5 is the amount of money at t equals 5 years. That means that $6,000, because m of 5 is 6,000, is the amount of money we have after 5 years. B. Using correct units, explain the meaning of m prime 5 in context. Well, we know that m prime t is the rate of change of m over t. I'm going to replace m with amount of money, t with time. So m prime t is the rate of amount of money. Sorry, m prime t is the rate of change of the amount of money over time. So m prime of 5 is the rate of change of amount of money at t equals 5 years. Well, the unit here, we're told that m prime of 5 is 2000. The unit of m prime t, or any m prime, is the unit of m divided by the unit of t, which is money over years in this problem. So m prime 5 equals 2000 means that the rate of change of money at t equals 5 years is $2,000 per year. I'm just plugging the 2000. The unit is $2,000 per year. Okay. So what did we learn? We learned how to explain the meaning of derivatives in context. You can use a sentence starter. The rate of change of something with respect to something is something. For example, well, if we have f prime of t, we can say that the rate of change of f with respect to t is f prime of t. So f prime of 3 would be the rate of change of f at t equals 3. If d of t is the number of dogs and t is years, then d prime of t is the rate of change of the number of dogs after t years. Okay. So the slope. So derivative means slope, which means the rate of change. All right, that's it.